Designing microgrid as a service agreements requires state-of-the-art design methods that combine intermittent renewables, combined heat and power, and distribution system modeling to meet high-value loads and offer resiliency and energy security to customers. Furthermore, with agreements that often have a financial guarantee on performance, operators need a tool that can give them confidence in project profitability while also remaining competitive against traditional distribution methods. Additionally, with constantly changing energy prices, tax incentives, and financing mechanisms, the solution has to be able to analyze changes year over year that may affect project viability or the overall investment strategy. Xendee is that solution. Xendee is an operating system for microgrids that helps engineers rapidly design and optimize distributed energy systems and operate them dynamically to meet organizational goals and maximize efficiency once installed. Let's take a look at how to run a multi-year analysis in Xendee. What we're looking at now is Xendee's conceptual designer, which allows users to place technologies of interest directly on a satellite map of the actual site location. With a basic design of the microgrid laid out, all we'll need to do is change the reporting years in the financing tab to match the number of years in our multi-year analysis. This will allow Xendee to optimize financing and investment over the 15-year life of the project, taking into account changes over time and not just generate the best single-year solution. Next, we'll need to set up our multi-year settings and specify anticipated changes over the span of the project. In this example, we expect solar PV technology and electric storage costs to decrease. Conversely, for electricity rates from the utility, we are anticipating an increase in non-coincident demand charges, peak demand charges, and natural gas. These numbers can also be further defined by the users to set the exact change in every year of the project, but in this example, we'll just leave a consistent rate of change. The final setting we need to make on this page is to define how long the multi-year changes should take effect. Once again, to match our financing settings, this will be set to 15 years so Xendee can consider delaying an investment or upgrading technologies as they become cheaper, or as fuel prices merit a change. To run the optimization, first click the Optimization tab, and then make sure Multi-Year Optimization is turned on and press Run. Once complete, the multi-year optimization now reports energy costs, carbon emissions, and annual energy costs by project year, allowing utilities and energy providers to get a much more accurate view of their operating costs over time. This can give providers not only more investment opportunities, as increasing energy costs may make projects viable that didn't appear so in a single-year optimization. Additionally, the increased detail over the lifetime of the project allows energy providers to more accurately set billing terms and ensure the projects will be financially viable in the long term. The report also includes a number of other elements, including a breakdown of the cumulative capacity of the microgrid over time. For example, because we enabled Xendee to suggest upgrades at any time over the life of the project, we can see Xendee has suggested including the installation of an electric heater in year 11, as natural gas for the turbine continued to increase in price. Users can also get a detailed view of each year by clicking on the corresponding link in the chart, which includes an optimized electrical dispatch that calculates the ideal energy generation, purchasing, sales, and dispatch at every time step of the day. Armed with these tools, energy providers can more accurately validate projects and set pricing that will be both competitive in the marketplace and financially profitable for the company. And even as the world actively seeks more sustainable solutions, competitive rates and profitability will be key to reaching a critical mass of distributed energy resources and reinforcing the resiliency, security, and sustainability of humanity's power grids.